Hi, and welcome to the last part of our exploration and production workflow. This part of the workflow, we're going to be focusing on using our cognitive interpretation workflow to interpret the data that we have within GeoTeric. May I please remind you to keep your microphones muted throughout the webinar, and there will be time for question and answers at the end of the session. My name is Rachel Moore, and I'm the Geoscience Manager at GeoTeric in Houston. So previously what we've done to the data is we started out with our full volume and we applied noise cancellation to the data to clean up the data so that we could then do a reconnaissance frequency decomposition blend. And this is the results of our frequency decomposition. This is a uniform constant Q, and it gave us the best relationship between vertical resolution and frequency resolution. This is a time slice through the Jurassic, and you can see these nice bright white amplitudes down here. And we do know in this area that these bright amplitudes do correspond to gas in the area. So we decided we would focus the rest of our workflow on this area to get a good interpretation of the area. So like I said, we started with our noise cancellation data. We then applied a low pass filter to the data to bring out the faults. And we just removed a little bit of the high frequencies so that we could bring out the faults better. And you can see as I flip back and forth between the noise canceled and the filter data that you can start to see these fault edges coming out a lot more. We then applied our fault workflow, and we have two different fault trends in the area. We have some listric faults over here to the side, and we also have some very planar faults. We decided that the tensor attribute worked best, and we took this through our fault detect and our fault in volume. So now we are ready to go through and work on our interpretation. This was the last image that we ended up with in the previous webinar. So this is our HD-FD blend, and you can see how well the fault trends highlight or surround these nice amplitudes in the HD-FD. Now we're going to go through and interpret a few lines. This regional horizon here is what we're going to interpret, but our area of interest of where the anomalies are down here. So I'm going to use GeoTeric's new adaptive interpretation system. And what I'll do is I will click and put a seed point in, and I'm able to do whole line tracking. I'm able now to scoot ahead 4 lines and then put in another seed point and do whole line tracking that way. And move again 4 more lines and do another seed point in there to look at the whole line and get it tracked. If I think my horizon should go up here, I simply hold down the shift key and it'll show me where the possible horizon could go. And if I move 4 more lines, then I can put another seed point in and I can demonstrate where the horizon should go, and then I can move back and make my adjustments as needed. I can now view these lines on the base map, and I'll just zoom in so you can see them a bit better. And now you can see the interpreted lines, and now I'll highlight the area that I'm confident in, and I will fill these. I'll lower the acceptance level so it's only filling areas that are very similar to what I have interpreted, and I'll press the fill button. And then you can see that we now start to have our horizon being filled in. And now I will go back through and we can look at these in the 3D section. So if I just start panning back through, we can check our interpretation to make sure that it is correct. And we can just zoom back through the horizons and check to make sure that we've interpreted everything that we are interested in. I can now bring over the base map and I can fill in this area that I have interpreted with a very low acceptance level and continue filling this in higher and higher acceptance levels until I am happy with the way that the horizon looks. And once I have created that, I can then go through in the 3D scene and scroll back through the inlines to QC everything that has been filled in. So now that I have my horizons interpreted, I'd like to go through and do some isoproportional slicing in between these two horizons. So if I go to the Reveal tab, I can go to isoproportional slicing, and this will bring up the menu. And I'm going to do this on our HDFD, so I'm going to select my color blend. I'm going to go to an inline, and do dual horizons. So if I choose my North Rankin as my upper and my top Mungaroo as my lower one, I think I will do, if I zoom in here, probably 12 slices in between those horizons because it is quite a bit of space. And I'm just going to look at the maximum amplitude and the RMS since I am using a color blend. So if I process this, it'll take just a few moments to run. But now we can start looking at our slices. So if we scroll down to the bottom, we just look at the max amplitude. We can now see we're down here at the base, and we can look for any type of stratigraphic features that we might find in here. And we're just kind of going to slice up through these and try to find any type of stratigraphic events. This isoproportional slicing is really good for finding any type of stratigraphic ascents. And you can see this is the area of interest that we are, these bright amplitudes here that are coming in that we are interested in. And I'm just going to continue to scroll all the way up. And if once you have looked at your data and you can confirm that you are happy with it, then you can go through to the export. And you can either just export the slice boundaries or you can export the slices, the center slices of each boundary with the data attached to it. So I'm going to go ahead and export out also the maximum amplitude and the RMS energy. And you just hit export button there at the bottom. I now have all of my horizons out from my isoproportional slicing, and I'm now going to add these. If I just highlight all of them, right click and send to create horizon pack. I'm going to create a horizon pack of these horizons. So if I just scroll down and do my horizon pack and bring this up, and I would like to have the data mapped on there. I'm going to put my HDFD blend. And if I go to the pack editor, that shows me all of my horizons where I can add or delete any horizons or change the order of them, but they should end up in chronological order. And then I go to display mode. What I want to do is add that to the scene. And it'll take just a minute to add to the scene. And if I tilt this back and push my horizon back, you can see I have all of these slices in here. And I just want, you can either display the full pack or the individual horizon. So I'm just going to display the individual horizon. I'm going to scroll down to the bottom and then I can display these as a movie. And I'm going to change the time of them to be 1 second delay. So if I just press play then, it's just going to scroll through and you can get a better idea of how your area of interest has been deposited by slicing through this data in a chronological order. And you can just let this play, so it'll go back up to the top and then it'll go back down to the bottom. Now that I have my horizons interpreted, I can go through and I can go to surface overlays, open this window up so I can see the surfaces, and I can double click on the ones that I would like to display. And you can see that I've got a top and a base, and the green horizon is our horizon of interest. And I'll just turn this on, this horizon on, and you can see I've got the HDFD already displayed along the horizon. And now I'd like to go through, I'll just remove those, and I will just bring up the HDFD, and I want to go through and capture a geobody on those areas of interest. I'm going to scroll down to the area of interest, and I'm going to make the volume just a little bit smaller so it's a bit more manageable to control while we create our geobody. And then I'm going to turn off the horizon overlays here by just hiding all of them. And then I'm going to click off my horizon and then scroll down to where our area of interest lies. I'll just zoom in a bit so that we can see this area a bit more. And then I'll go up to the Interpret button and I'll do Adaptive Geobodies and click on where we will put our seed points in for our adaptive geobodies. And I'll paint my area on this bright area of interest and go to the geobody over here and then click Adapt. And you can see this one comes to a stable state very quickly, so I need to increase my acceptance rate and hit play again. Now I can watch how this geobody grows in the 3D. And I'll just kind of zoom through the anomaly, scroll through the anomaly. I like to look and see how it is adapting. Just make it a bit smaller so I can manage the better. And I'll add in a few more clusters and then hit all clusters and keep adapting. And I think I'll increase the acceptance rate just a little bit more. There's still a few areas of this anomaly I have not captured. Add in one more cluster and hit play. And then I think that is a good geobody. Let's just scroll through and check. I think I have captured the anomaly quite well with this geobody. And so I will hit stop and then we'll. Now that we have the geobody that we are happy with, we can go through and we have the aerial extent of the geobody down here. But if we go down into more metrics, we can see that we have our inline extent, our crossline extent, the vertical, the total surface area, and the volume. We also have the interval velocity, which we can change. So we did lower it a bit, and so we end up with a volume of 0.018 kilometers cubed. So we have here our geobody, and we've calculated the metrics from the geobody. So now we can go up to our tools and go into STOAP calculator, and this is where we can estimate some recoverable value. So we're going to use gas initially in place, and we're going to change this to meters. And when we looked at our geobody metrics, it was 0.018 kilometers cubed. And when you convert that to meters cubed, it is 18 million. In the research that I've done, I found that this is a poorly sorted sandstone. So I'm going to put this down at 60%. Our porosity is also a very tight sandstone, so I'm going to put this down at 0.08. And our saturation at 40. Now these are only guessed, and some of these I have found some information for the region in there. I'm not quite sure of our volume formation factor for this gas, so I'm going to put this as 0.01. And so you can see here that we now have some metrics. I'm going to put this down at a 40% recovery factor also, because this is quite a tight sandstone, so I don't expect the recovery factor to be that high. So we've ended up with reserves of around 86 billion cubic meters of gas for this area. So to wrap up our exploration and production webinar series, we've conditioned the data and revealed areas of interest through noise cancellation and standard frequency decomposition. After determining an area to focus on, a low-pass filter was applied to the data for our fault workflow. We identified two fault trends from our fault attributes. Tensor attribute was best at identifying the trends, and we used a wider filter which was able to bring out more of the faults. We interpreted key horizons and used isoproportional slices to view the high definition frequency decomposition. The HDFD was able to localize the anomalies in order to capture metrics from the geobodies. We estimated our metrics using our STOAP calculator, and we have no wells that go through this anomaly, but there is a plugged and abandoned well nearby, so we are able to get some information from that well. So with this workflow, we were very quickly able to identify an area of interest and determine key features such as faulting and thickness of the anomaly. I hope this has been of interest to people, and I have really enjoyed working on this project over the past few months. Thank you very much for listening. So up next in May, our next webinar is going to be on our new adaptive interpretation system. You've seen a sneak peek of it today. It will be released in June, but Gaynor will be going over all the information on our new adaptive interpretation system. So please register for that. And then following that in June, our next our webinar in June will be all about our new release of 2017.1. So please stay tuned, and we hope that you will tune in for those webinars. Thank you. Hi, and welcome to the last session of our EMP webinar. Previously, we have done some reconnaissance work on a data set in the northwest shelf of Australia. We've noise canceled the data, and we've done a reconnaissance frequency decomposition. When we did the frequency decomposition, we did a standard uniform constant Q frequency decomposition, and we noticed at the end of the webinar we ended up with this very bright area in here. These bright areas are sometimes indicative of hydrocarbons. This enabled us, doing this reconnaissance frequency decomposition, enabled us to determine the target area to focus our detailed workflows on. So in the last session, we did some fault works, and what we did is we started with our noise cancel data, and then we applied a spectral enhancement in the target area to bring out these faults better. And as you can see on the enhanced data, that these fault cuts are much clearer now so that we can run them through our fault expression workflow. And when we did that, we determined that the tensor attribute was best for picking up both the planar faults and the more listric faults that we had in the data set. We also, in that webinar, created an HDFD on this targeted area. And you can see again that these bright amplitudes were here on the frequency, on the HDFD, and they were highlighted very nicely with the fault trends. Now we will continue with interpretation. We will interpret a few key horizons, and we will also interpret a geobody on the HDFD for metrics.